Have you ever wondered why a really cluttered website just gives you a headache? Well, it turns out the reason for that feeling is bizarrely connected to the very same problem that holds back even the most powerful AIs. Today, we are digging into this universal bottleneck that connects our brains and artificial minds in a way you might not expect.
Okay, let's start with something we've all been through. You click a link, you land on a web page, and bam, it is a total mess. We're talking ads, pock-ups, clashing colors, the whole shebang. You almost instantly feel overwhelmed, right? Maybe a little stressed out. So why does that happen? It's not just about bad design taste, it's actually about bad psychology.
That feeling of stress, that's your brain slamming into a hard limit. Scientists have a name for this: cognitive bandwidth. You can think of it like your brain's personal internet connection. You only have so much capacity to process information at any given moment. So, when a website bombards you with a ton of irrelevant junk, it just eats up all that bandwidth, leaving less mental space for you to actually do what you came there to do.
Right, so that makes a lot of sense for us humans. But what about a seriously powerful AI? You know, a large language model that can chew through billions of data points. Surely it doesn't get stressed out by a messy interface. Or does it? And that is the central question we're going to unpack today. And believe it or not, the answer, which comes from some really fascinating new research, is a huge yes. AIs absolutely have a cognitive bandwidth limit. But what's really going to blow your mind is that the trick to making AI smarter and more effective, well, it looks a whole lot like how we design things for our own focused, less stressed human brains.
So here we have these two incredibly powerful processors, the human brain on one side and an AI agent on the other. Both are trying to solve complex problems. But as we're seeing, both can get seriously bogged down. So let's take a look at each one, and we'll start with us.
All right, let's dive into our first case study here. How we can design interfaces that help our own brains learn and focus, without just wasting that precious mental bandwidth.
You know all that mental junk food we were talking about, the flashing banners, the confusing layouts? Well, the scientific term for that is extraneous cognitive load. It's basically any mental energy you spend on stuff that has nothing to do with what you're actually trying to learn. It is the #1 enemy of effective learning and clear thinking.
And this quote just nails the solution. The interface design expert Sharon Oviatt puts it perfectly. The absolute best design is often the design you don't even notice. It doesn't shout for your attention. It just quiets all the noise so you can focus on what actually matters. And this idea is at the heart of what's called quiet design. It's all about stripping away anything that isn't absolutely essential. For instance, get this. Research shows that a simple line drawing is often way more memorable than a super detailed photograph. Why? Because that kind of simplification makes information easier for our brains to grab onto, because it slashes that extraneous cognitive load.
Okay, so for us humans, the solution is simplifying the input. Now, let's pivot to our second case study and see how this exact same principle plays out in the world of AI, just in a totally different context.
So an AI agent that's trying to do something complex, say find a specific product on a website or run an experiment in a simulation, it also hits a bottleneck. Its version of a cluttered web page is an absolutely overwhelming list of all the possible actions it could take at any single moment. Now, there are two main ways we can give choices to an AI. On the left here, you've got planning with actions. This is like giving the AI a massive, super specific menu. Move apple to desk, move orange to table, move banana to counter. You get the idea. But on the right, we have planning with schemas, which is more like giving it a recipe from a cookbook. Move object to location. The AI has to do a little more thinking to figure out the specifics itself.
And this is such a critical shift in thinking. Instead of forcing the AI to churn through a gigantic, noisy list, the schema approach makes it do a bit more, well, reasoning. It has to take that abstract template and fill in the blanks, figuring out that the object could be an apple and the location could be a desk. The cognitive load shifts from just brute force processing to something a little more elegant.
And this brings us to the core discovery of the research. Which one of these methods is actually better? Well, it turns out there's a tipping point, a point where everything just flips.
Just look at this table. In a pretty simple simulated world called ALF World, the AI has, maybe 30 or 40 specific actions to pick from. But in a more complex environment, Psi World, that list just explodes to over 400 actions. Meanwhile, look at the number of abstract schemas. It stays small and totally manageable. The complexity doesn't just grow, it goes supernova.
So here it is, the million-dollar question. What do you give the AI? The giant specific menu or the short abstract cookbook? What is the most efficient way for it to actually think and get the job done?
And here's the punchline. In the simple environment, that long specific list, what the slide calls PWA, is way, way more effective. It just works better. But in the complex environment, the tables completely turn. The abstract approach, PWS, becomes significantly better. That long list just becomes too much cognitive noise for the AI to handle effectively.
Researchers call this exact moment the inflection point. It is the precise moment where the world just becomes so cluttered with choices that it's actually smarter to think abstractly than to try and process every single little detail. It's the AI's version of preferring a simple line drawing over a photorealistic image just to get the main idea across.
So let's bring all this home. What does this amazing parallel between human and artificial minds really tell us about intelligence itself?
We saw that for us humans, cutting through the noise is absolutely key. Simplifying what we see protects our limited cognitive bandwidth and helps us perform better. Simple as that.
And for AI, the exact same principle holds true. When it's faced with overwhelming complexity, simplifying its choices by using abstract templates becomes essential for it to work effectively. It, too, has a finite cognitive bandwidth.
So the big takeaway here is this. Intelligence isn't about processing an infinite amount of information. It's about efficiently managing a finite amount of bandwidth. Whether you're a student trying to learn from a textbook or an LLM trying to complete a task, overload is the enemy. The solution, it turns out, is the same in both worlds. Simplify, abstract, and find the signal in all that noise. Quiet design and planning with schemas are really just two sides of the very same coin.
And that leaves us with one last big thought to chew on. We often imagine superintelligence as this boundless, infinite thing. But this research strongly suggests that to build AI that is truly useful and can scale, we have to respect its limitations, just like we have to respect our own. So if the path to smarter AI is actually through designing for its cognitive bottlenecks, what does that tell us about what it really means to be intelligent in the first place?